Welcome to our lab exercise 6 video presentation. In this lab, we are going to show how to interface Keypad with Arduino Uno board. The objectives of this laboratory are to introduce the student to Arduino Uno hardware, Arduino software, writing, compiling, downloading, and testing programs to control 4x4 keypad using digital inputs on the Arduino Uno and interfacing various devices such as LED, switches, and piezo buzzers and keypad. The materials we used in this activity are breadboard with Arduino Uno, adapter, 220 ohms resistors, LED, and piezo buzzers. For the first program, we are tasked to do the following procedures. 1. Connect the Arduino Uno R3 compatible board to the Force4 keypad as indicated in the given table and graphics. 2. After the above operations are completed, connect the Arduino board to the computer using the USB cable. The green power LED should go on. 3. Open the Arduino IDE and choose the corresponding board type and port type we're using in this lab exercise. 4. Key in the code provided and save it as Program 1. 5. Before running this, we must import the keypad library and then, once imported, then enter it into the program. Once it's entered your program, we should see the line Issue include. If we do not see this, that means that the keypad library has not been successfully put into the code and it won't work. 6. A few seconds after the upload finishes, press a key on the keypad. It should show up on the serial monitor of the Arduino software. Here is the Tinkercad demonstration of program number 1. The materials needed are 4x4 keypad, connecting wires and Arduino Uno board. We connect the 4x4 keypad to the Arduino Uno board to its assigned digital pins. Here is the actual demonstration for program number 1. Program 2. Arduino Jukebox. Program description. This program transforms your Arduino into a jukebox capable of playing various melodies. When a key on the keypad is pressed, the corresponding song is played, and the LEDs light up in sequence, synchronized with the music. Materials. For this program, we'll use an Arduino Uno, a piezo buzzer, 6 LEDs, a 4R4 keypad, 7 PCs, 220-hour resistors, jumper wires, and a breadboard code. Here is the Tinkercad demonstration for program number 2. Code explanation. First, let's look at the hardware setup and how we configure it in our code. We have a buzzer connected to pin 12 and 8 LEDs connected to pins 4 through 11. These LEDs will light up sequentially when a song plays, adding a nice visual touch. We define a matrix where each character represents a key. The keypad library helps us link these characters to the physical pins on our Arduino. Next, we have the play tone function, which is the heart of our jukebox. This function takes in 3 parameters: frequency, duration, and pause. This function plays a tone at a specified frequency and lights up the LEDs one by one. The tone lasts for the given duration, and after it finishes, the LEDs turn off and there is a pause before the function ends. The Arduino Jukebox comes with 6 built-in songs. Each song has its own function, where we define the sequence of tones that make up the melody. In the setup function, we set the buzzer and LED pins to output mode and start the serial communication to print the song menu. This menu guides the user to select a song using the keypad. Finally, let's talk about the loop function. In this function, we continuously check if a key has been pressed on the keypad. If a valid key is pressed, it calls the corresponding song function to play the melody. After playing the song, it reprints the menu for the next selection. This loop keeps the jukebox interactive and ready to play songs on demand. Here is the actual demonstration for program number 2.
Twinkle, twinkle, little star.
Program 3. Hexadecimal Calculator Program Description. This program transforms your Arduino into a functional hexadecimal calculator. With the use of a 4x4 keypad, you can input hexadecimal numbers and perform basic arithmetic operations such as addition, subtraction, multiplication, and division. Materials for this program will use an Arduino Uno, a 4x4 keypad, jumper wires, and a breadboard code. Code explanation. The program starts by including the keypad library, defining the layout of the 4x4 keypad with hexadecimal digits and operators, and specifying the pins on the Arduino connected to the rows and columns of the keypad. Several variables are defined to store the input sequence, the operator, and the numbers involved in the calculation. In the setup function, we initialize serial communication at a baud rate of 9600. The loop function continuously checks for key presses on the keypad and processes them based on whether they are numeric, operators, or control keys. When a numeric key is pressed, it is added to the current input string, and the character is displayed on the serial monitor. This allows the user to build up a hexadecimal number. When an operator key is pressed, the program converts the current input string to a number, stores the operator, and clears the input string for the next number. When the .10 key is pressed, the program converts the current input string to the second number, performs the chosen arithmetic operation based on the stored operator, and displays the result in hexadecimal format on the serial monitor. If the shown key is pressed, the input string is cleared, allowing the user to start a new calculation. This ensures the calculator is ready for fresh input without retaining any previous data. Summary. The code for this project sets up the keypad and handles input from the user. It interprets key presses as hexadecimal digits or operations and performs the calculations accordingly. When you press a numeric key, it forms a hexadecimal number. Pressing an operator key like A for addition initiates the operation. Finally, pressing the key performs the calculation, and the result is displayed in hexadecimal format. Here is the Tinkercad demonstration for program number 3. Here is the actual demonstration for program number 3. Program 4. Password-driven. PSO buzzer. Program description. This program implements a password-driven PSO buzzer system using an Arduino. It prompts the user to enter a password. Depending on whether the password is correct or incorrect, a corresponding light sequence and tone will play. After 3 failed attempts, the keypad is disabled. Materials for this program will use an Arduino Uno, a piezo buzzer, 6 LEDs, a 4x4 keypad, 7 PCs, 220 Ohms resistors, jumper wires, and a breadboard. Code summary. The program starts by initializing the keypad, buzzer, and LEDs. It prompts the user to enter a password and compares it with the correct password. If the password matches, it activates the buzzer with a musical tone and lights up LEDs in a running pattern. If the password is incorrect, it displays an incorrect pattern on the LEDs and activates the buzzer with a different tone. It allows 3 attempts for entering the correct password. After 3 failed attempts, the keypad is disabled. Here is the Tinkercad demonstration for program number 4. Here is the actual demonstration for program number 4. And that's how you can successfully interface a keypad with your Arduino Uno board. By following the steps we've outlined today, you can easily add user input functionality to your Arduino projects. Remember, using a keypad allows you to create a wide range of interactive applications, from simple password systems to complex control interfaces. We hope this tutorial has been informative and helpful for you. If you enjoyed this video and found it useful, please give it a thumbs up and consider subscribing to our channel for more tutorials and project ideas. And don't forget to hit the notification bell so you won't miss any of our future videos. Thanks for watching and happy coding with your Arduino projects. See you in the next video.